we know we're looking for the shortcuts in this chapter. So we've already determined that side angle, side angle, side angle works, which led us to realize that angle, 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 side worked. But then we were able to break that down into angle, side angle, and angle, angle, side. And we know that angle, angle, angle doesn't work, right? So we have two that we do like. These ones, we know they work, but we're looking for the shortest way we can do it possible. So that's where we're at right now. And we're gonna look at some other conditions to see if they work, like side, 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 and some other stuff. So long story short, that's where we're beginning this section at, and we're gonna try more conditions to see what we can come up with. So 752 said Kendall knows from investigation in lesson 712 that even if two triangles have angles that are all congruent, the angle, angle, angle condition, they're not necessarily congruent. But Kendall wonders about side, side, side. It says, start by making a prediction. Do you think two triangles are congruent if all three pairs of corresponding sides are congruent? So it asks us to use the E-tool, but again, I'm brutal with using the E-tool, so I don't want to use the E-tool. What I do want to do is just sort of talk about it real quick. Let's say I have a triangle where like this is 10, and this is 8, and this is 6, okay? The thing is, essentially, can I put this thing together in a way that would make it not congruent to this one? So, again, if I took a side that was like 10, and let's say I decided to make this 8 go up like this, well, this 6, it wouldn't close this triangle. So that wouldn't work that way. I couldn't do that. If I wanted to take this 10, and let's say I wanted to make this angle go like way more steep, right? So here's my 8. Well, then the 6 would sort of go past it. And again, it wouldn't really make a triangle. It would make, you know, just sort of like this weird shape that doesn't quite close. The only way that I would actually be able to get this thing to close, sorry, I have a phone call, so I'm going to pause and continue. Got a phone call. So anyway, the only way that we would actually be able to close this triangle is if it had the same angles. And if it had the same angles, then that means that, yeah, it would be congruent. So side, side, side is a valid triangle congruence method. That's going to be the third one that we're going to have. So we have angle, angle, side, side, angle, and now we will add side, side, side to that list as well. By the way, I just want to point out that these would be right triangles, right? 6 squared plus 8 squared equals 10 squared. So the only way that would happen is if we had those right triangles. So that will work. So Kendall's excited that her team found a new triangle congruence condition, side, 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 but now wonders if she needs all three sides to determine congruence. So is side, side a valid congruent statement? And two sides isn't going to be enough, right? Because if we have a triangle that looks like this, again, right? Well, I could just go like this, and that's clearly not going to be the same triangle, but we have two sides. So side's not enough. All right, so Kendall's teammate Diego spoke up. We know side doesn't work in most cases, but what if the two corresponding sides are on right triangles, right? So this is kind of a special one. He says, I know that for sure these two triangles are congruent. Well, right, we're using what is known as the Pythagorean theorem to say that this squared plus this squared has to equal this squared. Well, think about what he's saying. If we put numbers here, again, if I say this is 6 and this is 10, and I say that this is 10 and this is 6, this has to be 8, right? 6 squared plus 8 squared equals 10 squared. 6 squared plus 8 squared equals 10 squared. So this is a special instance, right? This one is not special because we don't have a right triangle here. It won't close this way. But here we have a right triangle, and it forces it to be 6, 8, 10. So side has an interesting property if we're talking about a right triangle specifically. So it says, what would be a good name for the congruence condition Diego discovered? We're actually going to call it, which is interesting. Remember what this is called here. This is a right triangle. Oops, I didn't mean to get rid of all that, but I guess it doesn't matter. I don't know. I guess we'll leave that much there. Okay, so try this again and leave the triangles there. Ugh, so close. All right. Okay, so when we look here, you'll remember that these are called legs, and this is called the hypotenuse. And this is vocabulary we use in a right triangle. The side opposite the 90-degree angle is the opposite. The adjacent sides, adjacent means next to, the adjacent sides of the 90-degree angle are called legs. Well, if you look at this, we know the hypotenuse and one of the legs. So this is actually called the hypotenuse leg congruence. And we're going to add it to these three that we already have. So now we have angle, angle, side congruence, angle, side, angle congruence, and side, side, side congruence. So that's where we're at right now. So we've tested the following conditions. We said this doesn't work, this doesn't work, this does, but it's not a shortcut. We have this one and this one, and now we're adding side, side. I'm sorry, we have angle, angle, side as well, and we have hypotenuse leg. Those are the ones that we have that work here. All right, let's go ahead and, I don't know, I'm probably going to go to 715B, it looks like. I'm guessing 756 will be on that, but let's see. So 715B. So there we go, there's 756, a little bit cut off. I'll tell you, I haven't noticed so many getting cut off except for in this chapter. It's kind of interesting how many got cut off in this chapter. So I think it looks like this. I guess I need to come over here and look at problem 756. Let me pause this real quick. Phone for a few minutes, and I think I forgot where I was. I think we did 755, and I think we were picking up on 756, but I could be wrong there. So I apologize if this is redundant. Carlos then asks, what if we only know that one angle is congruent and the two pairs of corresponding sides that make the angle are congruent? Does this mean the triangles are congruent? So what about side angle side? Again, side angle side is important to understand that the A connects the S's and that the angle connects the sides. So what it's essentially asking us to say is, what if we took another triangle where we said this was 4, and we said that this was 5. I can't get my brain to work anymore. It makes me sad. Used to have a good brain, but no more. All right, so what if we know that this is 4 and that this is 5 and this is a 20-degree angle? Well, think about it. Is there any way that this is going to close where it's not congruent? There really isn't. So side angle side congruence is going to be another one that works. So we're up to our 5th one now. We have side side side. We have angle side angle. We have angle angle side. And we have the one that everyone always forgets about. It's only true if it's a right triangle, hypotenuse leg. By the way, I will say hypotenuse leg is only true if it's a right triangle, but if it's a right triangle, it doesn't mean it's hypotenuse leg. We'll look at more examples of that as we go. But it says test your ideas. So again, if I had one that was 3, 4, and 120 degrees, it would have no choice but to have the exact same triangle as this. So side angle side does work. The last one is side-side angle. And side-side angle is an interesting one because side-side angle ends up not working. However, there's really only 2 options for side-side angle. So if we have side-side angle, you're either going to get one that looks like this, where we'll say, all right, well, this is 4 and this is 5 and 49 degrees, and we can close it this way. Or there's one other way that you can do it. And it is, and I think the best, let me pause it real quick and show you because they're going to show it way better than I can for. I know that this is kind of in the way, but you can see that these have the same side lengths and the same angle. And if you can see that angle right there. But they go into it, I guess, a little bit in this video. Let me look for that still picture. That's the one I'm looking for right here, where you can see there's only 2 ways that this triangle will close. One of them is congruent and one of them isn't. So side-side angle, while it isn't always congruent, sometimes it is, and one time, like I said, there's 2 ways you can make the triangle, one that's congruent and one that isn't. So it is kind of interesting in the sense that there is like more limited options on that side-side angle. But the long story short is, again, even though there's 2 examples, they're not always congruent, although it's, I guess, more likely than some of the other ones that are not true to be congruent. but still not enough to prove triangle congruent. So again, these are our 5 shortcuts. These are the 5 that we're going to go with. That will close it out for the chapter. And side angle is going to be one of the ones that doesn't work. Angle will be one of the ones that doesn't work. Side will be one of the one that doesn't work. And again, these will be the 5 that do work.